Hello my dear students. Today I am going to start a new lesson for class 9th students, that is chapter 2 Polynomials. In this lesson you will be learning about what is a polynomial, what are the different types of polynomials, what is the zero of a polynomial, etc. etc. Once again I welcome you all to your own channel Noble Mathematics. Will find a way or make one. What is a polynomial? A polynomial is an algebraic expression in which the power or the exponent of each variable is a whole number, that is a non-negative integer. For that, to understand a polynomial, we must know what is an algebraic expression. I am going to write few examples of algebraic expressions, and from those examples we will find out which of them are polynomials and why. And also we will see which of them are not polynomials and why they are not polynomials. Here I have written few examples for algebraic expressions. First one is 3x plus 2y. Second one is x square minus 2x plus 3. Third one is x cube plus 2 root x plus 5. Fourth one is 8 by y plus 3y cube minus 6y. Fifth one is x square plus x plus 3x raised to 0.5 plus 4. Sixth one is 3x plus 4. All these are algebraic expressions. Among these, few are polynomials and few are not polynomials. So let us find out which of them are polynomials. What is a polynomial? A polynomial is an algebraic expression in which the power or the exponent of each variable is a whole number. Look at the first algebraic expression here, 3x plus 2y. Here the variables are x and y. The power of the variable x is 1 and also the power of variable y is 1. So here the power of both x and y are positive numbers, that is whole numbers. Therefore, this is a polynomial, and here there are two variables, so this is a polynomial in two variables. In this algebraic expression, you can find only one variable, that is x. And what are the powers of x? For this term, the power of x is 2. Here the power of x is 1. Here we have no x. So, in this algebraic expression also, you can see the exponents or the powers of the variable x are whole numbers. So, this is also a polynomial. Now look at the third algebraic expression. This is x cube, the power is 3. In the second term, 2 root x. In 2 root x, what is the power of x? You know that root x is equal to x raised to 1 by 2. Since root x is equal to x raised to 1 by 2, it means in this term, the power of the variable x is not a whole number, it is a fraction, so this is not a polynomial. Look at the fourth algebraic expression. This is an algebraic expression in only one variable y. In the first term, it is 8 by y. In the second term, it is 3y cube. And in the third term, it is minus 6y. In the second term, the power of the variable y is 3, which is a whole number. In the third term, the power of the variable y is 1, that is also a whole number. But in the first term, what is the power of the variable y? Actually, when you write 8 by y, it is equal to 8y raised to minus 1. That means 8 by y means 8y raised to minus 1. Here, the power of the variable y is a negative integer, so this is also not a polynomial. Fifth one, the power of the variable x are 2, 1, and here the power is a decimal number 0.5. So this is also not a polynomial. And last one, sixth, in the first term the power of the variable x is 1. Here you have no variable x. If necessary, you can add a variable x here by writing like 4x raised to 0, because you know that x raised to 0 is 1. So 4 into 1 you will get a 4 back. So in this algebraic expression also you can see the powers of the variable x are whole numbers. So among this algebraic expression, it is clear that the first one is a polynomial in two variables. The second one is a polynomial in one variable. Third, fourth, fifth are not polynomials. And the sixth one is again a polynomial in one. The next topic is, what is a polynomial in one variable? A polynomial in one variable is a polynomial in which there is only one variable, that is x or y or z. For example, x square plus 2x minus 3. This is a polynomial in one variable x. So generally, a polynomial in one variable x may be denoted as p of x. So here we can say that p of x is equal to x square plus 2x minus 3. P of x is used to represent a polynomial in the variable x. We can use f of x. F of x means that is also used to represent a polynomial in variable x. You can write f of y. F of y means it is a polynomial in variable y. For example, 3y square minus 8y plus 4. This is an example for the polynomial in variable y. That is, a polynomial can be represented by any one of the following: p of x, f of x, f of y, g of x, q of x, r of x, etc. Now we are going to learn what is degree of a polynomial in one variable. To understand the degree of the polynomial in one variable, let us write few polynomials in one variable. First one is p of x is equal to x square plus 2x plus 3. This is a polynomial in variable x. F of y is equal to y cube minus 3y square plus 2y plus 4. This is a polynomial in variable y. Then p of x is equal to x plus 4. This is also a polynomial in variable x. G of y is equal to y square minus 2y. This is a polynomial in variable y. Look at the various polynomials. All these are polynomials in one variable. The degree of a polynomial is the highest power of the variable in a polynomial. The highest power of the variable is called the degree of the polynomial. So here the first polynomial has the degree 2 because its highest power is 2. Second polynomial has the degree 3 because the highest power is 3. Third polynomial has the degree 1 because its highest power is 1. And the fourth polynomial has the degree 2 because its highest power is 2. So the degree of a polynomial is the highest power of the variable in a polynomial. Now, what is different types of polynomials based on the degree of the polynomial? Based on the degree of the polynomials are classified into linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial, constant polynomial, and zero polynomial. Let us see one by one. The first one is linear polynomial. A linear polynomial is a polynomial whose degree is 1. The standard form of a linear polynomial in variable x is P of x is equal to ax plus b, where a comma b are real numbers and a is not equal to 0. Example for a linear polynomial. P of x is equal to 3x minus 2. Here a is equal to 3 and b is equal to minus 2. So what is a linear polynomial? Linear polynomial is a polynomial of degree 1. The second polynomial is quadratic polynomial. A quadratic polynomial is a polynomial of degree 2. A quadratic polynomial is a polynomial of degree 2. The standard form of a quadratic polynomial is P of x is equal to ax square plus bx plus c, where a comma b comma c belongs to real numbers and a is not equal to 0. Example, P of x is equal to 3x square minus 2x plus 1. Here a is equal to 3, b is equal to minus 2 and c is equal to 1. The third one is a cubic polynomial. A cubic polynomial is a polynomial whose degree is 3. A polynomial of degree 3. The standard form of a cubic polynomial is P of x is equal to ax cubed plus bx squared plus cx plus d, where a, b, c, d are real numbers and a is not equal to 0. Example, P of x is equal to 2x cube minus 8x plus 3. This is an example for a cubic polynomial because its degree is 3. 2x cube minus 8x plus 3. You can notice one thing. Generally, after 2x cube term, the next term is possibly x square term, but here it is missing. Doesn't matter. That term can be considered as a 0x square. That means if you want to write it in the standard form, you can write it as 2x cube plus 0x square minus 8x plus 3. And now comparing with the standard form, a is equal to 2, b is equal to 0, c is equal to minus 8 and d is equal to 3. The next one is biquadratic polynomial. A biquadratic polynomial is a polynomial of degree 4. A polynomial of degree 4. Its standard form is P of x is equal to ax raised to 4 plus bx cube plus cx square plus dx plus p, where a, b, c, d, e, etc. are real numbers and a is not equal to 0. For example, here the degree of the polynomial is 4, so it is a biquadratic polynomial. But definitely you can see that here some terms are missing. X cube term is missing, x square term is missing. So to write it in the standard form, you can write those terms with the coefficient 0, that is 0x cube plus 0x square, etc. So this is a biquadratic polynomial. The next polynomial is constant polynomial. A polynomial of degree 0. What do you mean by a polynomial of degree 0? Any real number, that is rational or irrational number, can be considered as a constant polynomial. That is, for example, 3 is a real number, and if required, we can write it as a 3x raised to 0. So, here the degree of the polynomial is 0. You know that 3 into x raised to 0 is 1. 3 into 1, you get the 3 back. That is, any real number can be called as a constant polynomial. Another example, 1 by 2. 1 by 2 is equal to 1 by 2 x raised to 0. 0.5 is equal to 0.5 x raised to 0. Here I used the variable x. You can use any variable. That will not change the value of these constants. So every constant is a constant polynomial. The next one is zero polynomial. What is zero polynomial? Zero is called a zero polynomial. Zero is called a zero polynomial. That is, 0 is not a linear polynomial, not a quadratic polynomial, not a cubic polynomial, not a biquadratic polynomial, not a constant polynomial. 0 is a zero polynomial. Its degree is not defined. The degree of the zero polynomial is not defined because 0 can be written with any degree. For example, 0 is equal to 0x raised to 10. 0 into anything is 0. 0x raised to 10 is 0. And it is equal to 0x raised to 1000. 0 into x raised to 1000 is also 0. So the degree of a zero polynomial is not defined, or it is infinity. So these are the different types of polynomials based on the degree. Linear polynomial, degree 1. Quadratic polynomial, degree 2. Cubic polynomial, degree 3. Biquadratic polynomial, degree 4. Constant polynomial, degree 0. Zero polynomial, 0 is called a zero polynomial. Its degree is not defined. Here, while writing the standard form of each polynomial, I have written a is not equal to 0. You can notice. Why it is written that a is not equal to 0? If a becomes 0 in any of these polynomial, then the first term, that means here if a is 0, then this term becomes 0, then it will be a constant polynomial. It cannot remain as a linear polynomial. In the quadratic polynomial, if the value of a becomes 0, then x square term will become 0. So it will not remain as a quadratic polynomial. It will become a linear polynomial. So in every standard form of a linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial, you can see that the coefficient of the highest degree term cannot be equal to 0. The coefficient of the highest degree term cannot be equal to 0. So these are the different types of polynomials based on their degree. I hope all of you understood what is a polynomial and what is the degree of a polynomial and what are the different types of polynomials based on the degree. That is all for today. Have a nice day. Take care.